We tend to view the apex predator as a creature of pure aggression, a machine defined by its muscularity and its ability to kill. But high-speed pursuit is incredibly expensive. A cheetah's sprint raises its body temperature so rapidly that it often lacks the energy to actually eat its catch, forced to rest while stronger scavengers move in. Even the lion faces a staggering 70 specialized strategies that actually keep these animals at the top of the food chain. During a peak African drought, surface water vanishes and calorie conservation becomes the absolute priority. The leopard manages this energy deficit through extreme stillness, by using the dry terrain as camouflage and waiting for a mathematically favorable moment to strike. It avoids the wasted effort that kills less patient predators. In the open ocean, we see a similar shift away from raw power and toward complex cognitive coordination. This chart shows the result of that coordination. While lions and cheetahs struggle with high failure rates, orcas maintain an 80% success rate. They rely on techniques passed down through generations, effectively using collective memory to secure food. In a landscape where a single missed meal can be fatal, these cognitive tools and shared knowledge are more reliable than muscle. In the extreme cold of the Alaskan tundra, the environment serves as a filter that quickly eliminates any creature that is underprepared. The polar bear survives this freeze through a specific optical adaptation. Its fur is composed of hollow, translucent hairs that scatter light, mimicking the surrounding ice and snow with perfect precision. This allows the bear to remain completely invisible while waiting for days at a seal's breathing hole, turning total immobility into its most lethal weapon. Contrast that stillness with the Alaskan wolf. Instead of a fast sprint, wolves prioritize cardiovascular endurance, chasing their prey through deep snow until the target's heart and lungs simply give out. When the temperature drops, the utility of a quick burst of speed vanishes, leaving predators to win through sensory manipulation or relentless stamina. The Brazilian caatinga is an even more specialized crucible. Temperatures here can exceed 42 degrees Celsius, and surface water can disappear for an entire year. Capuchin macaques adapt to this scarcity by using stones as tools. They calculate the precise force and angle needed to crack open hard seeds that other animals simply cannot access. This lack of water creates dangerous concentrations of life. As water holes shrink, they become prime ambush sites for rattlesnakes waiting for dehydrated prey. But the white-eared opossum, or bibi, possesses a defense that defies the rules of this environment. Its blood contains a specialized protein that neutralizes snake venom. This microscopic view shows how the protein functions. When the venom enters, the opossum's proteins physically bind to the toxins, preventing them from attaching to cells. This immunity is so effective, the opossum can survive multiple strikes that would be fatal to any other mammal. This invisible biological shield represents millions of years of environmental pressure, where survival depends on internal chemistry rather than external strength. We can now define the apex predator not as the strongest animal, but as the one that most efficiently exploits the constraints of its biome. But these ancient strategies are beginning to fail because the biomes are changing faster than the animals can adapt. Arctic sea ice declined 40%. These specialized traits are the result of millions of years of selective pressure, but their future now depends on whether we can protect the crucibles that created them.